Hello, my name is Aaron Oliver Taylor and I'm from Gold Standard Phantoms. Today I'll be presenting ASLDRO, Digital Reference Object Software for Arterial Spin Labeling. I am an employee and shareholder of Gold Standard Phantoms. So, why is a DRO needed for ASL? For starters, the image analysis pipelines, such as the one used in Explore ASL here, are complex, involving many stages. We can use standardized datasets, either individual subjects or group averages, but they lack a known ground truth. Also, we need flexibility to cover the different implementations and parameter choices, as well as non-ASL data such as structural scans. Our DRO is written in Python and is released under an open source MIT license. The ASL signal is generated using the general kinetic model, then, for label images, encoded into the longitudinal magnetization prior to calculating the gradient or spin echo transverse magnetization. Rigid transformations mimic patient motion, and the image is resampled at the acquisition resolution before noise is added in the Fourier domain. This is repeated for each dynamic, constructing a 4D time series, which is then output in ASL bids format. By omitting the ASL signal generation, images with T1, T2 or proton density contrast can also be generated. By also omitting the MR signal generation, we can resample and transform the input ground truth quantity maps. We have implemented the software in a highly modular way, making it possible to extend and reuse components in new pipelines, and all the methods are fully documented. The DRO takes a ground truth image and a parameter file as inputs. The ground truth comprises a 5-dimensional NIfTY with volumes for perfusion and intrinsic MRI quantities, and a JSON file with single value quantities. Either built-in or separately provided ground truths can be used, with the built-in ground truths based on a widely known atlas. The parameter file configures how the DRO will run. Ground truth parameters can be overridden, and the quantity maps have scaling factors applied. Multiple image series can be specified, each with their own parameters. On the left is a time series of control and label images with patient motion simulated and the corresponding difference image. On the right are the results from running synthesized ASL and structural data with and without motion through Explore ASL. To demonstrate the DRO, we conducted sensitivity and uncertainty analyses to investigate how CBF values vary with input parameters and estimate the uncertainty in measured CBF based on reasonable parameter distributions. To achieve this, we constructed a model comprising generating the DRO data, then quantifying the CBF with the single subtraction equation and recommended quantification parameters. A 2-level full factorial sensitivity analysis was performed using all high and low combinations of these parameters. This allows us to determine how the mean grey matter and white matter CBF vary with respect to the input parameters varying. The uncertainty in the measured CBF was then calculated by running a 12,000 sample Monte Carlo uncertainty evaluation, in which parameter values were then randomly sampled from these reasonable estimates for parameter distributions. We also assessed the bias and linearity between input and output CBF by modulating the input CBF by a scaling factor between 0 and 2. In the sensitivity analysis, all chosen parameters were found to have effects larger than the standard error and hence significant, with the T1 tissue scaling factor the greatest. The uncertainty analysis gives estimates for CBF that are significantly lower than their ground truth values, this being due to bias from simplifications in the white paper quantification model. The associated standard uncertainties account for the between subject variability that might be expected. Estimating or measuring these parameters on a per subject basis with sufficient precision could lower this uncertainty and improve the bias. To summarize, we have presented DRO software for arterial spin labeling. The outputs of the DRO can be used for benchmarking and testing ASL image processing pipelines. Its modular architecture makes it readily extendable, and it can be used to investigate the effects of parameter variations as demonstrated by the sensitivity and uncertainty analyses. Thank you for your attention. I'd like to acknowledge our funding bodies and to encourage you to try out the DRO for yourselves.